Okay. Right. I want us to proceed with our functions and graphs. Basically, what we've covered so far is the new content which was supposed to be covered in grade 4. The rest of the other work that I'm going to do going forward is just revision of your grade 11 and grade 10, right? But purely examinable in grade 12. So let's do it together. Let's perfect it so that when it comes in exams, we'll be ready for it. Okay, right. Now, sketching of functions. Right. I want us to start with sketching of functions. I'm just going to group it into two. Right. The first one, the first lesson on this one, which is lesson 10, I'm just going to be looking at sketching a linear function and a quadratic function or parabolas. Okay, just those two. Then I'll go to hyperbolas and other functions in other lessons that are coming up. Okay, right. So let's try to look at this together. Okay, right. Now, let's go to the board. I'm going to start with a linear function. Right. Now, for you to be able to sketch a function, for you to be able to sketch a function, understand first what it means to sketch. Only concerned about the important features of that particular graph, just like when you're in grade 1 and you're asked to draw a person, right? Or a girl. You remember grade 1. Definitely, if it's a human being that you're trying to sketch, you need the head, you need the neck, you need the hands, the legs, the waist, everything. Those are the important features which makes up a what? A human being. Right. Now, that just the same thing with sketching of functions. Whenever we are sketching a function, the most important thing is to put up the important features of that particular graph. Okay, right. Now, so for you to be able to sketch any graph, all you need to present on your sketch diagram or on your Cartesian plane are the important features. So I'll go through each and every graph, citing the important features and how you're supposed to present it on a Cartesian plane. Okay, right. Now let's look at this is still under functions. This is under functions. This is under functions and graphs. Functions and graphs. Okay. Now, let's look at this. I'm basically looking at sketching. Of functions. Right. Now, the functions that I'm going to look at is, first one, we are going to look at the linear function. I'm going to look at the quadratic function, which is also called parabolas. The graph of a quadratic function is called a what? A parabola. Then the third one, I'm going to look at the hyperbola one. Hyperbolic function. The hyperbolic function is also called a rational function. A rational function, right? Then I will explain that as we go. Then exponential function. I'm also going to sketch a logarithmic function, the one that we covered this year, logarithmic function. The logarithmic function. Okay, these are the functions that I'm going to be sketching under this section. Okay, right. I'm going to start with the first one, which is a linear function. In this lesson, I'm only going to be looking at the linear function and the quadratic function. Okay, right. I'm going to start with the linear function. Right, a linear function, Right. The graph of a linear function is a straight line graph. This is represented by a straight line. This is represented by a straight line. A linear function is given by the expression, if you would go back, as a function or as an equation. This is given by y equal to mx plus a c from your lower grade, or in terms of functional notation, we say f of x is equal to ax plus a q. Right. Now, that's a linear function where m is the gradient, where m denotes the gradient of the line, and c the y-intercept, c the y-intercept, y-intercept. Okay, right, let me just stop there. Right, now look at this, good people. Whenever you are sketching these graphs, from your grade 10, the first fundamental thing is for you to be able to identify them when you see them. Just looking at a function, you should know that this is linear. How do you know that a function is linear? A linear function is identified by the highest exponent of x. So if the highest exponent of x is 1, then you know that this is what? A linear function. Okay, right. Now, how do I sketch it? How do I sketch it? Right. I will come to its important features. What are you supposed to present when you are sketching a linear function? You are only supposed to show us the intercepts, which is the x-intercept and the y-intercept, where the graph is going to cut the x-axis and the way the graph is going to cut the y-axis. This is what we call the intercepts. So just by showing us those two intercepts, then you draw a straight line which passes through those two. Then that's how you sketch a linear line. Okay, right. Now, so the important, I'll come and say important features that we are mostly concerned with when you are sketching a linear graph. It's only what? The intercepts. Intercepts. There are two intercepts, which is what? X-intercept. What do you know at the x-intercept? Y is equal to 0. And also the y-intercept. And at the y-intercept, when the graph crosses the y-axis, x is equal to what? 0. So all I'm going to do is to calculate these intercepts, show them on my graph, draw a straight line which passes through them. Then that's how you sketch a linear function. Let me quickly give you an example. This is one of the simplest graphs that we have in terms of sketching them. Right, sketch the graph of f of x equal to what? 2x plus 4. Right. Now, before I draw this graphs, before I draw this one, just trying to give you guys a basic background on this. There are two types of linear graphs. Either it's an increasing linear function or is a decreasing linear function, which is denoted by the gradient of the function. If the gradient is positive, then the function is going to be increasing. If the gradient is negative, then the function is going to be what? Decreasing. So there are basically two types, one which is increasing and the other one which is what? Decreasing. So just by looking at the function that is there, the gradient is positive, so my line is going to be what? Increasing. Okay, let me quickly sketch this one. Right, now I'm going to calculate my intercepts, my important features. First, calculate the x-intercept. Someone can start with y, is still fine. Right, when x is 0, y is at the x-intercept, y is equal to 0. So I'll go back to that and say y is equal to 2x plus a 4. But y is equal to 0 at the intercept. So this is 0 equal to 2x plus a 4. This will be negative 4 equal to 2x. Divide both sides by 2, divide both sides by 2. Negative 2 is equal to what? X. Therefore, x is equal to negative 2. In terms of a coordinate, this is now negative 2 and 0. Y is 0, x is minus 2. So I'm now writing it as a point so that when I sketch or when I present it on my Cartesian plane, I will not have a problem with that. Okay. Right. Okay, now let's look at this. Let's look at this. I'm going to come now and say, what about the y-intercept? Y-intercept, we know that x is equal to what? 0. So if I've got y being equal to 2x plus a 4, it means x is equal to what? 0. So I'm going to say this is 0. Remember, your c in this case is 4. So instead of substituting where there is 0 there, where there is x for 0, you can just come and say your c is 4. So it means the y-intercept is what? 0 and 4. Or you can substitute, it's still fine. Okay, now I'm sketching. I'll come and draw my Cartesian plane. Look at this. Look at that. It's a sketch, right? Label y, label x. Right. Now, there are two coordinates that I'm going to present. The first one is negative 2 and 0. So I'll come to my x-axis. Don't graduate. Don't show us negative 1, negative 2, negative 3. It's a waste of time. It's a sketch. You just come straight and say, this is where my negative 2 is. Right. So 0 and negative 2 and 0 is there. Then 0 and 4, you just come and label 4 there. Right. So my graph is going to cross there and it's also going to cross there. Then you take your ruler. Take your ruler. Right. If I take my ruler there, I'm going to draw a straight line which passes through the two coordinates, the two intercepts. So this is the graph of F drawn. On each and every graph, after drawing it, you should be able to show us the domain and the range. If you look at this, we did domain and range. Where does the graph start? It starts negative infinity. Where does it end? Positive infinity. So I can just come and say the domain of this thing is what? X element of all real numbers. What about its range? What about its range? Range from negative infinity, that is below, to positive infinity, that is above. So the range of this thing is just y element of all real numbers. So if this is f, your f inverse, I'm just joining your lessons. It means your the f inverse domain becomes what? X element of all real numbers, and its range is also what? Y element of all real numbers. That's how you draw a linear function. That's the most important thing. The domain and the range, it was just a bonus. In actual sense, wherever we are going, each and every graph, as we are looking at it, we should also come up with this domain and range so that we can link it up with the other lessons that we did. Right, let me go quickly to the parabola, how to sketch a parabola. Okay. Right, sketching the graph of a quadratic expression, quadratic equation. I'll come and say, let me write here, quadratic function. Right, I'm going to underline that. We want to sketch a quadratic function. Right. Sketching a quadratic function. Sketching a quadratic function. The graph of a quadratic function is called a parabola. Right. This graph is called a parabola. We developed that in the lower grades. But the most important thing is to identify this function. Then you know that this is now a parabola. How do you know that this is a quadratic function? A quadratic function, its highest exponent, it is an expression with the highest exponent of x being equal to what? 2. That is basic. That is from your lower grade. A quadratic equation, a quadratic function, you identify it by what? The highest exponent of x. Right. A quadratic function is presented in two different forms. The first form, we call it the standard form. Right. The standard form. Right. How does it look like when it's in standard form? It is given as y is equal to a x squared plus bx plus a c. In other words, look at the highest exponent of x there. It is a 2. That is to show that this is a what? A quadratic equation, okay, or a parabola, okay, right. That is the first form. Then the next form is also, it can be presented in what we call the completed square form. The completed square form. Good. So your parabola comes in two different formats. It's either it is in the standard form or it's in a completed square form. In a completed square form, it means it will be y equal to a x minus a p all squared plus a what? A q. This is the completed square form. At this stage, one should be able to convert from standard form to completed square form or completed square form to standard form. We did that in grade 11. Okay, right. As we go, I'll try to also expose you to such so that you don't get intimidated. We did that in grade 11. It was a prerequisite. Okay, right. Now, if you look at this one, I'm now looking at sketching a parabola. Sketching a parabola. Okay, right. Now, for me to be able to sketch a parabola, for you to be able to sketch a parabola or the graph of a quadratic expression, you need the important features. What are the important things that we should present on a parabola? Important features. Right. Now, the important features of a parabola, what are they? The first thing is the shape. How does the shape look like? What determines the shape? How do I know that the shape is going to be like this? I'm sure from your lower grade, you now know of a what? A bell-shaped parabola and a cup-shaped parabola. There are two types of shapes, the cup-shaped and a bell-shaped, a sad face or a smiling face. Right. Now, how do I know whether it's going to be a cup-shaped or a bell-shaped, a sad face or a smiling face? Right. A determines the shape. If A is greater than 0, I'm talking about the coefficient of x squared, that A on your parameters there, right? If A is greater than 0, then it's going to be what? A cup-shaped parabola. Then it's going to be a cup-shaped parabola. Then the shape of the parabola is going to be something of this sort, which is also called smiling face or cup shape, right? Smiling face in the sense that if you go back to your Cartoon Network, you will have something like this. And if you put something like that, that person looks very happy. So this is going to be what? A cup shape parabola. Okay, right. Now, if A is less than 0, then it's going to be a what? A bell-shaped parabola. You can call it bell-shaped. Look at the bell, the old-fashioned bell, or in Cartoon Network, we say what? This is going to be a sad face. Look at this, and there's your eyes. This person is frowning, sad. Okay, but it's all in the name of trying to make you remember that if it's facing concave downwards like that, then it's A is what? Less than 0. If it's concave upwards, then what? A is greater than 0. So we can call it concave up, concave down, bell-shaped, cup-shaped, that kind of a thing. Right. Now, the next thing, the next important feature, it is the what? The intercepts. What do we know? X-intercept, y is equal to 0. Y-intercept, x is equal to what? 0. That's the next important feature. The next one, C. This is the one which separates all the other graphs from the parabola. The parabola, its main feature is the turning point. It is the turning point. It is the turning point. Okay, right. Now, the turning point. Turning point is deduced in two different ways, right, depending on the type of a function that you have. If you look at the standard form and you want the x coordinate at the turning point, you are going to present it as what? So let me just say standard form. In this side, I'm going to say what? Completed square form. Right. In standard form, for me to get the x coordinate at the turning point, you can just say x is equal to what? Negative b all over 2a. Then you get the x coordinate. Get the value of b, get the value of a, substitute that, and evaluate. You get the value of what? The value of x at the turning point. Then y will be equal to f evaluated at negative 2 over a, which is the value of x at the turning point. Once I get the x value at the turning point, I will use it to come up with the y value in that format. Okay. In a completed square form, the turning point is given by p and q, something like that. That will be in completed square form. You'll see that as we'll be going through examples. But the whole point is when something is in completed square form, the turning point is just a matter of extracting it. It's not something that is going to be really taxing. It's something that is going to be straightforward because it's a matter of just getting your P and your Q. Right. Remember, your completed square form is y equal to what? A x minus a p squared plus a q. So it's just a matter of saying if you are given an expression like say y is equal to 2 in bracket x minus 1 whole squared plus 3. So in this case, your p is going to be 1 and your q is going to be 3. So in this case, the turning point becomes just 1 and 3, something like that. Okay, we are going to go through that. We are going to explore on that. Very important. The next one, it is D, the last one, which is called the what? The axis of symmetry. Axis of symmetry. Now, the axis of symmetry is a line which divides the parabola into two equal segments, right? If I've got something like this, and this is my parabola going like that, and I've got a line which cuts the graph into two equal segments. That is your x equal to negative b over 2a, right? This is the line of symmetry or axis of symmetry. So the axis of symmetry, we know that x is equal to negative b all over 2a. Remember, at the turning point there, that's where your p is. At the turning point there, it is where x equal to negative b over a is. So it's either you calculate it by as x is equal to negative b over 2a or x is equal to p, something like that. This is in completed square form. This is when the expression is in standard form, something like that. Very important. Okay, right. The last thing there, it is being able to deduce the domain, the range, and the domain. Range and what? The domain of a parabola. Okay, now if I've got for the range, if you are given a bell-shaped parabola like that, or concave down parabola like that, this is P, this is Q. All right. Now, if I want to come up with its range and it's in this form, you can see that it starts from negative infinity, which is below, to Q. So it means the range of this will be Y less than or equal to Q. You can see you are starting from negative infinity right up to Q. So Q is the maximum value of Y. So we are saying Y can only be less or equal to Q. Right. Now the next one, if it's a cup shape like that and you want to determine its range, this is still PQ because it's a turning point. It is the turning point. And this turning point, we call it a minimum turning point, minimum TP. This one, we call it the maximum TP, something like that. So for me to get the range when it's a cup shape like that, you can see that it starts from Q and it ends to positive infinity. Okay, so your range is going to be what? My range is going to be Y greater or equal to Q. Look at that. Look at that. That's the range of a parabola. What about domain? Right. If I look at domain, I'm going to say it's either the graph is cup-shaped, right, with a turning point P and Q. But in this case, I'm looking at where it starts and where it ends along the x-axis. So you start this side, it's going to be negative infinity. It ends that side, it's positive infinity. So domain is going to be x element of all real numbers. What about when it's cup shape? Look at this. Look at that. Where does it start? It starts from negative infinity and it ends positive infinity. Remember, domain is analyzed along the x-axis, where it starts and where it ends along the x-axis. So it means domain is what? X element of all real numbers. What are you noticing? Whether cup-shaped or bell-shaped, the domain of a function is always what? X element of all real numbers, unless it was what? Restricted. Okay, right. That's very crucial. Okay, these are the important features of my parabola. Those are the important features of our parabola. Let's look at a typical example. Let's look at our typical example. Right. Looking at an example. Let's look at an example. Right. I'll say this is my example number 1. Right. Let's look at our example. Let me write that one again. Example 1. Right. Let's look at example 1. The question says, sketch the following. Sketch the graph of f of x, which is equal to x squared plus 2x minus 8. Right, the question just says sketch, so I'm supposed to show all the important features on my graph. All the important features. So I'm going to come and say, first things first, it is the shape. On my important features, shape. What is going to be the shape? A is greater than what? 0. You can see that A in this case, A is 1, B is 2, C is negative 8. So since A is greater than 0, so it means this is going to be a cup-shaped parabola. Okay, right, or concave up. Right, I'm now calculating the intercept. Y intercept, x is 0, right? So y is always 0, and c, in this case, your c is negative 8. In other words, if I put 0 where there is x squared, 0 where there is 2x, you can see that you only remain with what? Negative 8. Okay, so that is going to be what? Your y intercept. Now I'll come to x-intercept, where what y is equal to what? 0. So I'll come and say y is equal to x squared plus 2x minus 8. But y is 0, so it's 0 equal to x squared plus 2x minus 8. I'm now solving for x. This is going to be what? Factorize that. This is 0 equal to two numbers that will multiply to get negative 8. If you add them, you get positive 2. So I'm going to open two brackets there quickly. This bracket there is x, that bracket there is x. Right, the two numbers will be what? Positive 4 and negative 2. That's how you factorize that, I guess, and pray that you guys, you are well grounded on your factorization. Right, the next thing is, if this is x plus a 4, x minus a 2, this is equal to what? 0. Equate each bracket to 0, which is x plus 4 equal to 0, or x minus a 2 equal to what? 0. So your x is equal to minus 4, or your x is equal to a 2. Right. I'm now stating that as a coordinate. This is minus 4, 0. This is 2 and 0. I have to show this point on my Cartesian plane. Okay. Now I'll come to the next one, which is the turning point. Since my expression is in standard form, I can just come and say my expression is in standard form. The turning point is going to be what? X is equal to negative b all over 2a, something like that. So I'm going to come and say my b in that case is a 2, my a is equal to 1, and your c is equal to 8. In this case, I don't need c, so x is equal to, I'm substituting, minus 2 all over 2 times a 1. Simplified, that will be what? Negative 1. So your x is equal to negative 1. I'm going to use it to come up with y. So on the turning point, y is equal to f evaluated at the x value at the turning point, which is negative 1. So I'm going to substitute. Then I'll say, plug it back into the original expression, that is negative 1 all squared, plus 2 times negative 1 minus an 8, which is 1 minus a 2 minus an 8, which is equal to negative 9. So it means the turning point is going to be negative 1 and negative 9 if I'm to present it as a coordinate. Okay, right. So I'm going to say, let's sketch this. Let me sketch the function. It's a matter of me just collecting all the points and put them on my Cartesian plane. Okay, let's look at these points and let's try to sketch it together. Okay, right. If I'm to sketch this, I'm going to come and say, there is your Cartesian plane. I'm trying to come up with the sketch. There you go. There you go. Right. Now, this is y, that is x. Okay. Right. My intercept, I've got negative 4. I'll come and label. I've got a 2. Good. Right. I've got what? Negative 8 and 0 and negative 8. I'll come and say there. Then I also have a turning point, which is negative 1. I'll come and say negative 1 is there, and negative 8, which is somewhere there. Okay, this is going to be negative 1 and negative 9. There you go. This is going to be, I'm now sketching. How do I join these points? I know that the graph is going to pass through that point, that point, that point, and also that point. If you look at it closely, you'll see that this is going to be a cup shape, because I'm going to be guided by the shape that we deduced from the expression. This is going to be a cup-shaped parabola, so it's going to come out like this. There you go. Remember, it's a curve. It turns there. That's your parabola drawn. This is your f of x drawn. Right, on that f of x, one should be able to come up with the domain. One should be able to come up with the what? With the range. Okay, right. Just as an extension to this, a separate question, determine the domain and range. Determine the domain and range of f and f inverse. Okay, it's still fine. I'll come to my f this side and I'll put my f inverse that side. Remember, once I get the domain and range of f, then for f inverse, I don't need to come up with it. I can deduce it. Right. What is the domain of f, which is the drawn graph? You can see that this graph starts from negative infinity, right, to positive infinity. Okay, so it means x is an element of all real numbers. What about its range? What is its range? This is a cup-shaped parabola, and there is a minimum at -9, and the maximum, it is positive infinity. So y is greater or equal to -9. It starts at -9 going towards positive infinity. Okay, so the range, the domain and the range of the inverse this time is going to be what? X greater or equal to -9 and y element of all real numbers. Remember, in the previous activity, we said that which restricts the domain in F, it is the restriction of the range in what? In F inverse. That which restricts the range in F is the restriction of the domain in F inverse. That's how you deduce that. Okay, thank you. Let me look at my last example there. Then you guys will be fine on this sketching. Okay, let me just do example number 2. Right, let me just do example number 2. Right, let's look at example number 2. Right, look at example number 2. Right, example 2. What does it say? Sketch the following. Let's look at the next one. I'm just going to sketch the following expressions. Okay. Sketch the function. Sketch the function f of x equal to 2 in bracket x plus a 1 whole squared minus 8. Okay, sketch this function showing all important features. Okay, right. Just like any other parabola, I can see that this is a parabola which is in completed square form. So I'm going to come and say shape still determined by a. Your a is 2, so a is greater than 0. So it's going to be what? A is greater than 0. All right, just for interest sake, allow me to say -2 there, then plus there, just for interest sake, so that this one also becomes a what? A bell-shaped parabola. I did a cup shape in the previous activity. So if a is -2, it means if a is -2, it means it's less than 0. Then it's going to be a bell-shaped parabola. Okay, I just wanted us to look at something which is bell-shaped, because the previous exercise, it was cup-shaped. All right, thank you for that. Right, let's look at the intercept. Y-intercept, x is equal to what? 0. So I'll go and say y is equal to -2 x plus a 1 whole squared plus 8. Right? But x is 0, so I'm going to say -2, 0, plus 1 all squared plus an 8. This is going to be -2, 1 squared plus 8. So that is -2 plus 8 if I simplify, which is 6. So this graph is going to cut at 0 for x and 6 for y. Okay, I'm now coming to the what? To the x-intercept. X-intercept y is equal to what? 0. So I'm going to come and say y is equal to -2 x minus a 1 all squared, x plus a 1 all squared plus 8, something like that. Right, but y is what? y is 0. So I'm going to say this is 0 equal to negative 2 x plus a 1 all squared plus 8. Right. Now I'm solving for x. Solving for x, I can transpose the first term because there are two terms there. This term and that term separated by a positive. I can transpose the negative 1. I'm trying to make x subject. Or you can take 8 the other side. Then it becomes negative 8 equal to negative 2 in bracket x plus 1. Whichever way, someone can take this, the other side, then it will be the same thing. Divide both sides by negative 2, that and that cancels. You've got 4 equal to x plus a 1 all squared. When an expression is in a completed square form like this, avoid opening of brackets. Some of you guys, you are quick to open brackets, taking it to standard form. It will be a little bit long. Now from there, I'm just trying to make x subject. There is a square there, and the inverse of a square is the square root. So I'm going to square root both sides. Something like that. This becomes plus or minus a 2 equal to x plus a 1. This I'm going to break into two expressions. There is a plus 2, which is going to be equal to x plus a 1, or there is a minus 2, which is also equal to x plus a 1. Now, I'll solve for x. We're starting with the first one. Transpose that, it will be 2 minus 1 equal to x. So it means in this case, your x is going to be equal to 1. This graph passes through 1 and 0. Right, come to the next one. Transpose that, it's negative 2 minus 1 equal to x. So it means x is equal to negative 3. So this coordinate becomes negative 3 and 0. So I can safely write, let me rewrite those coordinates of the intercept. The first one is 1 and 0. The other one is minus 3 and 0, something like that. Okay, right, there you go. Those are your coordinates. Right, those are our coordinates. The next thing is to determine the turning point. How do I determine the turning point? Remember, this is a completed square expression. This is a completed square in a completed square form, right? This is y equal to negative 2 x plus a 1 all squared plus 8. Right, now in completed square form, I'm comparing it with the general one, which is x minus a p all squared plus a q. When it's in general one, the turning point will be p and q, something like that. Look at that. In this case, u is minus 2. Right, what about your p? What is your p? There was a negative p, but in my expression, there is x plus 1. Meaning to say, in this case, my p is minus 1. That's why there's now a plus inside that bracket. But if there was a minus inside the bracket, p was going to be equal to 1. So what it means there, for me to compare and get a negative, this is as good as x minus a 1. That's why I'm now taking my p to be negative 1. Okay, right. So once you've got a positive inside the bracket, then it means the sign of p becomes a negative. What about q? Q is straightforward. It's equal to what? 8. So the turning point of this graph becomes negative 1 and positive 8. That's the turning point. Okay, right. The axis of symmetry, axis of symmetry is still fine. For sketching, it's not much of a problem. You can sketch without the axis of symmetry, but we know that it is x equal to p, and your p in this case is negative 1. Okay, right. I'm now sketching. Look at how I'm going to sketch this. I'm going to draw my Cartesian plane. There you go. There you go. Right. I'll start with my intercept. The first one, it is 1. The other one is minus 3, so I'll come and say minus 3 this side. My y-intercept, it is 6, so I'll come and put 6 there, right? So the graph will pass through there, and there is 1 there. Okay, right. The next thing is the turning point. It is negative 1 and 8. Negative 1 in there is there. 8 is somewhere there. I'll come and label it negative 1 and 8. But what type of a shape is this one? It is a bell-shaped parabola. So it means I'm going to say bell-shaped parabola. When I'm joining that, I should come up with a bell-shaped parabola, something like this, passing through all the important points. Okay, so when someone is assessing, someone is marking, the most important thing is first the shape. Is the shape correct? You get a mark. Are the intercepts, x-intercept correct? You get a mark. Y-intercept, is it correct? What about the turning point? Those are the things that we are worried about. Those are the most the important features that makes up a what? A parabola. Okay, so that is how you draw such a parabola. Just to wrap it up, I'm still also going to do the domain and range, of f inverse and also f of x. Okay, right, let's try it. We are done with sketching. That's what we expected. Just extending this work. Determine the domain and the range. Okay, it doesn't mean when they say sketch you have to come up with domain and range, but I'm just trying to stretch it since we did that. Right, domain and range. This is x element of all real numbers. You can see that starting from the left side, it goes towards negative infinity, and at the right side, you can see that it goes towards positive infinity. Okay, right, so from negative infinity to positive. What about range? It starts from negative infinity, which is the bottom, and the maximum is 8. So I can say the range to this is y. Y what? Y is less or equal to 8, because we are starting from negative infinity right up to 8. Then the domain and range of the inverse. I don't need to draw the inverse. I can deduce it from domain and range of f of x. That which restricts the domain, it means this side is y, element of all real numbers, then x less or equal to 8. That is the domain and range of f inverse. Okay, this is how you sketch a parabola. This is how you sketch a parabola and a linear line. Right. You can also be asked to draw these graphs, both a linear and a parabola, on the same set of axes. I'm also going to give you an activity, a quick activity on this one, and you attempt it at your own convenience. Then I'm going to post more problems on our platform. Let's follow us. You'll be able to pick and learn from this activity. Hope you benefited out of this lesson, and hope to see you, and hope you follow us in the next activity or next video or lesson, where we are going to be looking at the sketching of a hyperbolic function, exponential function, and a logarithmic function. All right. Thank you so much. Enjoy. Keep following EduBlush. Goodbye for now.